Hello, so this is a short video that's been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. Specifically, we're focusing again on our dynamic universe here, and we're looking at motion in relation to equations and graphs. So let's dive in. Here is the question. A city bus accelerates away from a bus stop along a flat road at constant acceleration. Which pair of graphs correctly show the displacement and acceleration of the bus over time t? Well, there we have the set of 5 options. So what's our approach? Well, again, we're going to read the question closely and pick out the things we're being asked about. Which pair of graphs represents displacement and acceleration for a bus accelerating constantly? Look at the options, see if there's anything obvious we can ignore. Well, let's not say there is at this point. Recall that we're still in the dynamic universe part of the course, so we can ignore the other stuff. And then read the question again slowly to calm yourself down, if nothing else. And avoid overcomplicating. If you find yourself lost in the possibilities, you're probably overthinking things. So just step back and start again. So what are we faced with here? Well, clearly we're looking at the relationship between displacement, movement, velocity, and acceleration. And this is only asking you to think about the shapes of graphs between each of these 3 things. And it may help to think of these things in the real world, like what the bus is actually doing. We know the question says that acceleration is constant. So if acceleration is constant, then it stays the same. So that would suggest that it looks something like this. It's a flat line, it doesn't change. So acceleration is constant. Let's just say it's constantly 10 meters per second squared. What does that mean for the velocity? Well, if you're constantly accelerating, it means you're constantly getting faster and faster. So velocity we expect to not be constant, we expect it to be getting faster and faster. And what should that look like? Well, because the acceleration is constant, not changing, then this velocity should also increase in a way that isn't changing. So it is a diagonal line up the chart, up the graph. And if the velocity is getting faster and faster, what does that mean for what's happening on the ground? Are you covering the same distance every second, or are you covering more and more distance every second? Well, in fact, you're covering more and more distance every second. Your displacement is getting faster, but not constantly faster. You're covering much more ground every time you accelerate a bit more. Sorry, every time you increase your velocity a bit more. If the acceleration looked like this, what would that mean? That would mean that your acceleration isn't constant, it's increasing more and more, which means your velocity would be increasing even faster and your displacement would be increasing even more than that. So to start with, we know that we're looking for constant acceleration. So some of our graph pairs must at least include a constant acceleration. They can't include acceleration that is increasing because that's not what we're told is happening. So let's have a look at our choices. It can't be D because acceleration is constantly increasing. It can't be E because acceleration is constantly increasing. So we've got it down to 3. Now we know that each of the accelerations is correct in A, B, and C, but look at the displacement. We know that for A, this displacement can't be right because if acceleration is constant, then velocity would increase like that, and we know then that displacement would have to do this, or something like that. Now, because we've established that, we know it's not A, and we know it's not B, because this graph in B does not look like the blue line in A. Therefore, it can only be C because that's what we're left with. And in fact, C is the correct pair. So this isn't asking you to do any calculations, which is interesting. It's asking you to just think about a car on the road and imagine what those look like. As long as you grasp that the acceleration is constant, it doesn't change, therefore the number stays the same. And there's the correct profile for each of acceleration, velocity, and displacement. Key things to note here, don't overanalyze the words like flat road. It mentions a flat road, a city bus. These are just context and not really that important. Do think of that everyday scenario. That's enough to answer the question, really. And here's some other examples that are available on the Hi page, hi.page/physicsfysx, and the answers for these are also there. So, another question successfully answered. Well done. Thanks for watching, and remember to subscribe.